那就会有一些那个问答的环节。
What does imatest do? We develop software for image quality testing, and we provide custom test charts and standard test charts for doing that testing.
所以我们到底 imatest 做什么呢？我们就是开发软体来测试图像质量，就是我们拍摄的画质，尤其是给这个数位影像。
We manufacture and resell equipment for test labs, such as lighting, collimators, motion generators for R&D.
那除了软体，我们也有硬体，我们也制造不同的设备来符合测试实验室的需要，包括灯箱、增距镜，还有这个动态模拟的这些设备，然后就是用来 R&D 用的，就用来。我们还有这个测试的图卡或者说导表。
Our tools are used in test machines for assembly and manufacturing and calibration of cameras.
我们也可以作为这个相机本身的这个 calibration， 就是这个测试它的这个校正。然后我们这些的系统呢，不管是硬体、软体，还有我们的测试图卡都是可以是合乎现在业界的主要标准。
We offer training and consulting services, and we are heavily involved in defining image quality testing standards.
我们也有提供像训练、付费的训练，还有顾问，然后就可以想要帮助不同的行业。去达到你想要得到的 R&D， 还有R&D 的目标，还有达到的产品的画质，然后所以可以达到业界的一个标准。
So this is some of our main products. Our main software products are imatest Master that has the user interface, and imatest IT, which is a programming interface.
所以这是我们主要的产品线。imatest Master 呢，它这个就是使用者界面的，非常方便来去连接。然后另外 imatest IT 就是工业测试版本，它适合用在于大批量像产线上面，它是有 API 的接口。
imatest Ultimate is a license that combines both of those software together in one.
右边我们看到 U 就是 imatest Ultimate 这个版本，它就是这两个版本的结合。
We have a range of test equipment for setting up generating targets for your test lab.
那这边中间蓝色的部分，我们看到这就是我们其他的，在你的测试实验室里面可以提供的，让你测试更加准确、方便的硬体设备。
And then we have a variety of test charts that we produce on different materials, depending on what your spectrum is, your field of view, and your distance. We have many different options.
那在最下面这一行呢，我们看到我们提供在不同材质、不同制作方式的测试图卡，那适合用在不同的 FOV 或者不同的测试的距离，还有不同的所需要不同的拍摄的这个光谱。
These are the standards we're involved in: the IEEE Automotive Image Quality and Camera Phone Image Quality Standards.
这里呢，就是我们有参与的制定的标准，像 IEEE P2020，汽车的车载系统、汽车行业的，还有这个 CPIQ 的标准。
And for within ISO, we are involved with the working group 18 TC42 Digital Photography Working Group, which has many standards.
那在 ISO 里面，我们在 TC42的这个工作小组，我们都是组员。
Some of the recent advancements, we've created a new user interface that allows you to start with the files first and has automatic identification of your targets.
那在我们最新的操作界面里面呢，我们可以从文件，就是你的这个档案图像直接来工作，然后软体会自动来侦测你要去测试的是什么样的功能。
We have many different test charts which we design And a lot of what we're trying to do is to test a lot of different features, a lot of different image quality factors with a single test chart.
那我们的目标就是缩短大家所测试需要的时间，还有过程。所以在我们这些很新的开发出来的测试图卡里面呢，那就是可以在最短的时间，在一次的测试里面，就可以给大家最多的测试的结果，还有需要的功能去测试画质。
So our chart technology includes large, high-quality inkjet prints, smaller, higher precision film targets.
那这些的尺寸，它可以有很大的，而且也是很高品质的这个打印机喷墨打印机打印出来的。那也有高精度的这个菲林，就是我们的底片的这个材质所打印出来的，所制作出来的测试卡。
Our highest precision chart technology is chrome on glass. And we also have a variety of targets for infrared and thermal cameras.
那我们最精度的、最高的呢，是一个玻璃镀铬的玻璃形式的，通常是用于像内视镜这样子的医疗系统，或是非常短距的。那在我们还有近红外线，还有感热的这种不同的关于客户所需要的这个测试图卡。
We have released a target generation library, which can create virtual targets that you can use for simulations of image quality.
那么现在也有虚拟的这个测试图卡或导表，你可以去在这个软体中产生，所以你可以有虚拟的测试图卡。
And we're about to launch a new line of charts that work much better in near infrared.
那在近红外的这些测试上面，还有测试图卡，我们现在正是我们放优先的这个开发的部分。
Okay, so we do have a special kind of software called arbitrary charts where you can design your own target and fill in the definition of that target, and then we can automatically analyze that custom target.
我们软体里面有另外一个功能叫做任意图卡，你可以设计你自己有需要测试的任意图卡在这个功能里面。
Okay, so next we'll talk about different image quality factors that we measure.
我们现在来讲不同的图像的要素，我们可能会关心想要测试的。
So there's a range of different factors we'll go over. We won't cover absolutely every factor, but maybe we can get into some more during the question and answer.
那像这里有列表出来，大家通常所关心、所测量的这些画质的要素。那我们可能今天没有时间把每一项都说完，可是我们可以说最重要的几项。
And at the end, I'll be going into more details about some of the automotive metrics that are being produced for P2020. But first, we'll start with sharpness.
那我一开始在我们今天的最后，我会讲一个车载系统，就是汽车行业P2020这个标准所讲的这个测试。那现在我先开始讲一下这个 sharpness， 就是清晰度。
So we rely a lot on the slanted edge feature for measuring sharpness. It allows us to very precisely measure one specific spot on your lens.
那我们这个测试的方式呢，是比较多仰赖于大家现在所看到的斜边，因为我们比较希望用斜边来测试清晰度，是因为它可以在一个图像的上面，可以在某一个位置比较精细的可以测试出来那个位置的清晰度。
Now, if your system has a lot of signal processing, like sharpening, then the slanted edge becomes less reliable, less accurate under that kind of signal processing. So other targets might be appropriate.
当然，在我们这个好处是可以测试特定位置的清晰度，但是这个斜边对于锐化过后的处理它比较敏感，所以如果说这个是一个高度锐化过后的一个图像的话，那这个对于锐化以后 的图像的测试就没有这么的可靠，所以的时候就会建议，如果是测试高度锐化的图像，用不同的测试图卡。
Another a kind of texture target for measuring resolution or texture preservation is this spill coins, which is a version of the dead leaves target.
这个闪避图或是很多人会称之为枯叶图的，是在测试这个细节。
So by having a low contrast target, which is challenging your signal processing to remove the details of the target as it thinks that they're noise, this can help tell how well texture details are preserved in your scene.
那在于低对比度，那就比较挑战于这个可以呈现出来的细节纹理，尤其是如果它很难去分辨什么是噪声或什么是真正的细节纹理。
For measuring noise, we need to have kind of even patches that we can analyze. And we look at the signal to noise ratio as well as visual noise that you can perceive in that patch.
那在测试噪声的部分呢，我们可以测试信噪比 SNR， 那也可以测试这个是这个主观的这个噪声。
So for measuring dynamic range, we look at a range of illuminations from bright to dark, and we say, when do we have good contrast? When do we have good signal to noise ratio?
那像这个动态范围，它是从亮到暗，我们就可以知道说最好的 SNR 的部分在哪里，信噪比的位置。
So if you have too much noise or not enough contrast, then you can't resolve details in your scene. You've lost your dynamic range.
比如说，如果说你过多的噪声，可是很低的对比，那就是就会太多的噪声，而失去我们真正的图像，就失去了对比。
So dynamic range is scene dependent. So depending on what kind of scene you have, how much stray light is present in the scene, you may have different dynamic range results.
所以这个时候我们就会测出非常低的这个动态范围。那尤其是杂光会影响动态范围测试非常大。
So we use a mask over our 36 patch high dynamic range target to kind of simulate something that looks more like a night scene, or we can remove that mask and simulate something that looks like a day scene.
就像是这个我们图像上看到的，上面这个我们就是有一个光遮罩，那它就是模拟暗夜或者很低光照的时候的一个拍摄的状况。那把这个光遮罩拿掉，那就是模拟，那这个就是模拟这个白天的状况。
Another, we also measure color accuracy, how appealing colors are using reference values of color targets, which are processed for your scene.
像我也可以测试色彩，那就是可以去针对是你比较喜好的色彩来做指定，或者是你要去测试是相近于标准的色彩。
And then we can also look at a flat field, a uniform field, to see where how your light fall off is in the corner of the image, and also whether there's any defective pixels or blemishes in the image.
我们还可以测试均匀一致性还有瑕疵，就像是不是有镜头渐晕，从这个中心到周围这个光度还有均匀性的变化。还有是不是这个镜头或者是 sensor 本身，它或是拍摄出来的图像有任何的瑕疵污点或是噪点坏点。
We look at distortion and properties of lenses, which cause the magnification to change as you go to the corners of the image.
我们也可以测试畸变，看是不是整张图像上面是怎么样的放大倍率的改变。
So that, and then this metric that we're working on developing right now is for flare or stray light, and this is a very complicated metric that involves a large number of images to really understand where the stray light is produced from your system.
现在看到的是我们正在开发的，这是有关于杂闪光 的一个研究。那因为大家也知道，早闪光对于我们拍摄出来的画质会有相当直接的影响。那这是非常复杂的一个开发，因为它会要包含这个成千上万的图像来做研究。
And we'll get into a little more detail about this when we get to the automotive focus section.
等一下，我们讲到车载系统，就汽车行业的这个话题的时候，我们会再更深入的来讨论。
So now I'm going to go over some of the imatest equipment that you might find in a test lab. We have a range of equipment that can work well with each other. We have this kind of system called the modular test stand.
这个是我们在实验室里面的一些设备，它可以相互的来搭配来使用。
This is an example of what some of these modular test stand parts look like. We start with the base module, which is a camera and chart holder.
那这个都是我们模组式的。那最左边上面的这一组呢，它就是最基本的，它有一个这个 dolly， 就是它可以有一个引导的这个轨道，然后还可以有一个非常固定稳定的放置测试图卡的一个架子。
We have a system to integrate reflective lighting, to accommodate wide fields of view, or to hold a light box onto the test stand.
那在这个基本的架构之上，我们可以左右有增加光源箱，可以调整角度的光源箱，或是可以比较宽的 FOV， 就是广角的拍摄。还可以有一个这个背投式的光箱这样子的支架。
We have visible LED lights, a filter you can put over them to achieve very low light levels in your lab, and also infrared lighting.
那在这右边呢，我们右边第三个可以看到，我们还有可见光的 LED 的灯源箱。那它可以加上滤片，然后可以去调整你想要的亮度，可以到非常非常低照度。
And then we have attachments that allow for producing motion, linear motion, and we have a target projector which can simulate a long distance in a compact space.
那在左下角，我们也有一个让图像可以可以去设置移动的速度，还有它的这个是线性的，然后中间的这个部分也有可以模拟长距的这个增距镜这个设备。
For measuring light and the uniformity of light, we have these devices called the ISOLIGHT puck, which you can control where they're placed to measure the light uniformity and intensity across your.
右下角这个符合 ISO 的叫 ISOLIGHT puck， 那这个是在一个导表上面，或是你要测试的一个这个图像上面，在不同的点你可以看到它不同的光衰减或是这个亮度。
And we also have a spectroradiometer, which can get the spectral properties, a very detailed spectrum of the lighting that you're working with.
右下角这个是光谱的测试仪，这可以很清楚的来测试你的这个光的光谱，在拍摄的这个实验室里面。
So depending on what your working distance or what your working distance is, you may need a entirely different test setup.
所以这个端赖于你所需要的拍摄的距离，所以你需要不同的硬体的设备。这边我们现在看到的左中右就是短距、中距和模拟的长距。
At close ranges, you'll need a high precision test target, and usually we'll use a light box to light those targets.
如果说你是测试是短距的，那通常是你需要是左边这种背投式的光箱，那上面所带的所配合的是比较高精度的，虽然是尺寸小，但是是相当高精度的测试图卡。
At medium range, this is somewhere around 50 centimeters to 3.5 meters. This is where the modular test stand is a really good option, and most kind of mobile devices, consumer electronics, and are using these kinds of medium range tests.
那 大部分不管是可能手机的相机，或者是大部分的一般的镜头，或者是手持的相机，都会用中间这种中距型的测试的一个环境，在实验室里面，它所适合的是50公分到3.5公尺。
For cameras that have a very long focal length, they may have a minimum focus distance that is many meters away. And for this, you may not be able to practically fill your field of view with a test target that works well in a normal size lab. In this case, a simulation of virtual image is what to do to test your camera.
最右边这个是长距的，尤其是如果说在拍摄的要求最低的这个拍摄的距离就已经是几公尺以上，就会用这样子的模拟长距的拍摄增距镜。那尤其是在一般的这个图卡的尺寸根本不可能去符合你这个充满你整个 FOV 的时候，就用这样的增距镜。
So the goal of trying to fill your field of view at your working distance, we can do that with this collimator fixture by having this intermediary optic that creates this virtual image.
那这个是可以去模拟你这个长距的拍摄，在一个相对来讲是不可能达到这么大范围的这个工作的空间。
So this fixture has been very, very popular with automotive companies that have focus distances as long as 15 meters or even longer than that.
尤其是在汽车行业，他们所需要的可能常常是测试是至少15米以上，15公尺以上，那就会需要这样子的一个增距镜，在一个比较小的测试的范围，用光学来模拟这个测试的范围还有图像。
The challenge with these relay lens or target generation systems is, well, they're much more costly than the other types of target systems. And they also may only fill a limited size of image entrance pupil for your camera.
那当然这套设备会比刚刚我们前面所介绍的2套这个价格昂贵许多，而且它可能它就是进入这个瞳孔的是比较有限的。
So for a 120-degree field of view, the entrance pupil it's able to accommodate is about 5 millimeters in size.
所以如果说 FOV 是在180度，在120度左右的话，那可能这个一个人进来可能就只有5个 nanometer 这样子的一个大小。
We also have a 70-degree lens that can fill a 15 millimeter entrance pupil.
那如果说是70度的话，那就可以进入这个镜头的，这就可以是15公厘。
So if your lens is much larger than 15 millimeters, these target systems aren't going to work properly for that kind of lens, like a DSLR.
就像 DSLR， 如果说你所要求的是大于这个15 millimeter 15公厘的，那但是是这个多于70度的这个视角的话，那可能就还是没有办法用这样子的系统。
So some other equipment you might have in your lab, there are light sources like an integrating sphere for very uniform light source across the spectral range.
那不管如何，在这个一个理想的测试的实验室里面，这个均匀的光源是非常重要的。
And then we also have tunable light sources for producing a much more accurate lighting that is closer to daylight than your normal sort of fluorescent or LED sources may produce.
所以我们这个可调式的光源呢，有不同的形式，那就是为了要最好的去模拟你所需要的，不管是日光的或者是夜间的这个光源。
So now I'm going to talk some about automotive and challenges that you will find in the automotive industry related to image quality.
这个车载系统方面，我们碰到了很多挑战，现在我们先这样讨论。
So in automotive, you need to deal with a very wide range of illumination, from really dark night scenes to staring directly at the sun.
在车载系统上面呢，我们会碰到更多不同的环境上的挑战，比如说有非常非常暗的在夜间的一个光源环境，或者是直射到这个太阳光底下。
The light level may change very rapidly as you go in and out of shadows. You may have to deal with those bright sources like headlights being pointed right into your camera.
那在光的亮度的这个反应也需要非常的快速，你可能是一下是在非常亮的这个阳光下面马上进入阴影，从阴影下直接进入非常大的阳光，或者是直接正对着对方来车的头灯。
And there's a large range of operating temperatures from minus 40 to 85 degrees Celsius is the typical range that you want to have your automotive camera tested at.
那在操作工作的这个环境温度也是有非常的极端，可能是零下40度的摄氏度，或到85度的摄氏度。
So typically, environmental chambers are used to simulate that kind of those kind of temperatures.
所以在测试的时候也要去模拟这样子的一个温度环境。
And then there's weather, rain, snow, sand, dirt, fog. All of these things can make the camera non-functional.
那在气候上面也有非常极端的气候的挑战，比如说像下雨下雪，然后沙尘暴或者是大雾等等。
And then with the camera system hardware, there's many challenges there, such as getting multiple camera systems aligned with each other.
那在一个工作的可能性，就是用很多的不同的多个 camera 多个相机一起来工作。
With fisheye lenses, it's very difficult to fill the field of view, or it's impossible if the lens is wider than 180 degrees. So you have to have three-dimensional targets to test those kinds of lenses.
而且在车载系统上面常常会用到鱼眼这个相机，鱼眼的镜头，那这个那多于180度，在一般的这个测试平面的导表或者是测试图卡上面不可能实现的，所以这时候就要用不同的测试方式。
So the different types of HDR and the challenges that exist in the real world, which are different than a test lab, can make testing dynamic range quite challenging.
那在很高的HDR，就是很高动态范围的这个 sensor 上面呢，那也有很多的挑战，因为在很多不同的这个环境下面。
And then as far as dealing with the camera data, I mean, it all goes into a artificial intelligence. And so the question is, how well does the camera performance, the objective camera quality correlate with the performance of that artificial intelligence?
那还有在这个主观的这个相机本身所产生出来的数据，跟我们人眼看到的数据能够相合，就是结合现在的 AI 人工智慧的系统。
So these are just kind of all the things that make testing automotive cameras hard. We talked about the HDR. There's also some novel types of color filter arrays, besides the normal sort of RGB filters.
所以刚刚我们提到，就是我们所碰到的车载系统上面最多的挑战，那还有很多测试上面的这个挑战，比如说像不同的 RGB 这个，还有这个还有不同的线性的或者是非全局性的这个响应，还有不同的色域。
So a lot of times you're in automotive, you're dealing with a black box camera, or you're not actually able to control the camera and you're not able to obtain raw images.
有的是测试这个黑箱的 camera， 黑箱的相机，那根本就没有办法去控制这个相机。
We talked about wide fields of view, long working distances. There's also, non-visible response that might be a concern as well. Different wavelengths of light, radar.
刚就是刚讲到不可以去控制相机，所以也没有办法控制这个 RAW， 就是这个然后再来呢，我们也没有，比如说很宽的 FOV 或者是很长距的这个拍摄，或者是没有办法肉眼所见到的响应，比如说是近的，或者是短波、中波，或者是热的这个感热式的，或者是这个近红外，都是人也没办法看到的。Yes.
The image signal processor, every vendor has a different approach, and they will cause different results in the end image.
还有不同的 ISP， 因为他们都有不同的方式来做 ISP， 来做这个影像的这个处理、图像的处理，所以这也是非线性的，也是非一致性的。
So one trend we're noticing is that there's actually lower and lower resolution cameras are coming out. The goal is to be more sensitive and also have less power consumption.
那越来越多是比较低分辨率的相机现在出来了。那它的目标是它可以越低的耗电，可是它可以提供越好的精度。
For high resolution cameras, there's this bandwidth problem and power consumption problem working with high resolution cameras. So those are less common in automotive.
那在车载系统上面呢，比较高精度的，它会有一个问题，觉得它比较耗电，那而且它的这个带宽这些都是它的问题，所以它这个比较不是非常的常用。
There's also cameras that are not meant for imaging, such as there's these event cameras and also LiDAR systems.
那有一些并不是图像式的这个 camera， 那就像是 LiDAR 这种的，或是 event camera。
So imatest is involved with the P2020 Automotive Image Quality Standard, which is part of the IEEE Committee of Standards.
那在 IEEE 里面，其中一个车载系统上面的标准就是P2020， 那我们也就是它的制定这个标准的研究小组成员之一。
So all of these companies, there's a big group of companies and individuals that are dedicated to making the automotive camera measurement a very standardized process. And we've been working many years and trying to achieve that goal.
那这个我们都有在这上面呢，就是一些部分的多于50的这个最主要的一些成员。那我们已经非常多年的来要有这样子的共同的目标，要把车载系统的标准制定得更为完善。那有其他的多于大概300个这个参加研究的一些大的公司。
So there are a collection of subgroups that are dedicated to different types of metrics, and these are the metrics that are currently under development in P2020.
那这边现在大家所看到的就是 P2020 主要在研究并且要达到标准的这些一些 metrics 一些项目。
So I'm going to go over these metrics and talk about, some of the differences that are going to be happening in the P2020 standard.
好，那所以接下来我一个来跟大家来讨论一下。
For resolution measurement, I mean, this is kind of the same sort of slanted edge method, but we're using the step response next to the slanted edge so that we know how to linearize each slanted edge appropriately.
我们这个是主要用于有一些的接调，所以说我们可以看到它的这个线型的响应。
And then there are adjustments to make it support wide field of view cameras, including and also long range cameras, such as positioning the target in the center versus the corners to test the full field of view.
所以这里这个可以测试远距，可以测试广角。
We have a metric for the geometric calibration, which will tell you how well your camera intrinsics are calculated.
这里也有几何校正的这个测试。
So we measure precisely measure the points of these targets, how far away they are, the angle between them.
所以就如图像上看到的，我们可以去测试它不同的在这个位置，还有这相对于这个相机它的角度，在不同的角度上它的位置，然后作为几何校正。
So the goal is to see, based on where you think these rays may exist in the real world, what the difference is between where you expect them to be and where they actually are.
那这可以校正说，在你期待它在什么位置，跟它真实的位置这之中的点，你认为它的位置和它真实的位置。Yes.
So we have a service where you can send us cameras and we will do this sort of validation of their calibration on those cameras as a service.
那我们有一个服务，就是你可以把你的相机寄过来，我们可以帮你做这样子的校正 ，GCV 的校正。
For dynamic range, the challenge is to deal with these different types of exposure combination. Sometimes you may have multiple exposures leading to a single image.
那在动态范围的挑战上面，就是大家可以现在在右上角的图像看到，它可能是有多次的曝光而形成一个图像。
So as you go, if you see a signal to noise ratio like this, where it's going up and down, well, this is a sign that something interesting is happening. There's been a combination of different exposures, or there's some sort of processing that makes the SNR not just a kind of linear function.
那在右边上面这两个图，我们都可以看到，它可能是有多次的曝光，然后所以有形成的单一的图像。那它的信噪比就有一直上下的这样子的波动。那也有可能是经过信号处理，所以它最后形成的结果并不是一个线性的一个信噪比。
For noise measurements, we're extending the ISO and EMVA standards to account for different environmental conditions, trying to match the type of conditions you'll face in your camera.
那这也包括了
situation.
EMVA 这样子的标准，在这个 P205里面来测试这个噪声。
And then we're looking at the measurement of or how well an automotive image sensor can mitigate or remove flicker from LED lights.
那在这里面有一个很重要的，也是在这个 LED 的 flicker 它的闪烁，那是不是可以去抓取到这个闪烁，可以计算出来？
So when you're doing a very short sample to take an exposure from a camera, and you have a pulsing LED, those things may not be synchronized, and you may miss the pulse of the LED, and that light may disappear.
就像是如果说你是这个曝光是非常短，那可是没有办法抓到这个 LED， 它这个在这个屏上面它有亮与暗之间，所以那就没有办法很正确的计算到。
So as automotive cameras need to be able to distinguish between a brake light and a turn signal, it's very important that they have this kind of flicker mitigation in their sensor and that it works.
所以这个FM 这个很重要，就是比如说你的相机，你在车载系统上面，它是不是可以去侦测到这个刹车灯或者是方向灯这样子闪烁的 LED light。
The metrics, actually, let me talk about one last metric before I talk about flare. So contrast detection probability. This is a metric where you're trying to see, like, what is the chance of me detecting an object in a scene of a particular contrast?
就这个 CDP 就是用来去测试我们刚刚所提到的这个问题。
We can use the contrast resolution, the imatest contrast resolution target as a way of producing those different contrasts within different tones.
所以在我们的这个分辨图卡 imatest 里面，分辨图卡里面，这个功能就可以测试这个 CDP 对比分辨率。
The metric that we're going to first support for P2020 fully support is this flare or glare stray light metric.
那现在在我们的软体里面就可以完全的支援这个 P2020 的这个杂光或闪光的测试。
So this is a modification of the ISO 18844 standard, where we're trying to make that much more comprehensive, so we can see where exactly your camera is going to have problems with stray light.
那这跟ISO 18844是一样的，那这个是用相同的方式来去测试杂闪光。
So our test setup for this involves moving a light source across the scene and seeing where that produces stray light. You can see some very interesting pedal and shower flare in this image here.
那在这里是一个所模拟的杂闪光，你们可以看到在真正的光源的周围有很多的杂光和闪光，还不同颜色的产生。
So I think the first metric we're going to release is called point spread rejection ratio. And as P2020 is finalized, we'll also release the metric that they recommend.
那在新的这个 P2020 里面也会有这样子点光源的杂闪光，还有点扩展这样子的一个规范。
This P2020 process is it's still in the standard is like planned for pre-release before the end of the year.
那在今年年底以前，它就会有一个初期的发表。
And we are rolling out the imatest version of these tests, starting with stray light or flare, beginning later this year, and the other metrics are going to come in 2023.
那在明年2023年的话，会有一些更新的一些关于这方面的发表，在规范里面。
Okay, that is the end of my presentation. And so now we can have a question and answer session. So if you have any questions for me, you're free to raise your hand using the hand raise button, or you can paste a question into the chat.
所以现在这是我很快的做一个介绍。那如果有什么问题，欢迎现在你可以直接在我们的对话，或者是可以举手用直接来问答，或是可以用写的。
So the first question we had is, do you provide high resolution charts that can be displayed on 4K or 8K monitors?
第一个问题我拿到的陈先生问说，我们有没有提供高解像度的这个在4K 或8K 的 monitor 上面使用。
So we have this tool, which is a Python library that can generate targets, variety of different targets. So you can this is actually a free tool. You can, after you buy this for $0, you can get this tool and it can generate targets, a variety of different test targets.
那我们是有这个用 Python 的这个 library， 你自己可以去生成你想要的这个测试图卡。你这边刚刚寄了一个连结给大家，那它是你可以去买，可是是用0元来买这个功能，然后就可以自己生成自己所需要的测试图卡。
And so this target generator can be useful for trying to do simulations of camera systems and seeing, how your artificial intelligence and your objective metrics of your camera can correlate with each other.
那这个图卡生成器它就是用 AI 来模拟，然后你可以来测试以后，知道说它这个模拟出来测试图卡跟你所需要的有多少的这个配比性。
So let me send this link for this article I wrote last month or in June on correlating the performance of computer vision with objective image quality.
那我现在来跟大家分享一下我在6月的时候1个多月前所发表的一个文章。它这个里面呢，就是主要我在说明的这个主观的图像的这个画质跟这个计算机，就是电脑的计算机的这个 computer vision
So
有什么样的差别
？In this article, we went through simulating a bunch of different types of tasks like reading text, reading QR codes, identifying faces.
那里面就包含说，不管是读这个 QR code， 或者是文字，或者是人脸识别。
And then we did a simulation using the images that are test chart images from the imatest target generator and these other types of images. And we added noise and blur to those images.
那这里就是由我们的 imatest 的图像生成器所生成的模拟的图像，然后我们可以用来把它调整成不同的图像，还有模拟这个模糊度清晰度，然后来测试，看这个机器的视觉跟人眼视觉之间的差别。
So we were interested to see, with different amounts of blur and different amounts of noise, when does that make your ability to detect these people or these characters, when does that degrade that ability?
在这个主观画质的改变上面，然后我们再用机器视觉和人眼视觉之间来做一个比较，来看这个我们的对于这个清晰度的这个变化的反应。
So we use this imatest target to generate the objective metrics for sharpness and noise. And then we plotted those to see, okay, how does our SFR correlate with the level of blur?
所以我们就之后用我们刚刚看到的这张我们的这个SFR 的测试图卡，然后来测试噪声还有清晰度，然后就可以看到这个它的清晰度跟噪声的改变，对于这个像值的改变。
And then we also looked at our noise metric and how well our SNR correlated with the added noise in the scene.
那在这下面这一张这个信噪比就看到，在这个画质上面，如果说我们增加了更多的这个模糊，那跟这个信噪比它的相对的这个关系。
And then we looked at like how well our computer vision worked across the different MTFs and SNRs. Where did the text identification work successfully?
那在这个图上，我们就可以看到，在机器视觉上面，它对于这个这个字的这个，它可以看到多少，然后就 MTF 50。
And so you can see that
来看，还有这个平均的信噪比。
For the text identification is very heavily correlated with the MTF 50 or the sharpness.
对，就刚刚提到，就是说对于侦测文字的话，尤其是对于 MTF 50这个指标比较有意义。
For QR codes, there was just an area where you needed enough sharpness and noise for that to work, or enough signal, lack of noise for it to work.
那在看侦测 QR code 的时候呢，那就是比较低的噪音，会比较需要有帮助，所以对于噪声它是比较敏感的。然后还有它的清晰度必须要清晰，然后少的噪声。
For the facial recognition, the noise also heavily impacted the ability to identify faces. And so a lot more than the noise impacted the other tasks we tried.
那在人脸侦测上面，噪声也是占非常大的比重，就是相对于其他它的测试上面来讲。
So I think maybe I'm happy to answer any more questions people have. I haven't gotten other questions, but I'll just leave you with this to say, okay, for your automotive object detection, what quality of camera do you need for that detection task to be successful?
这也端赖于你需要用到的这个应用，所以就是看在这个不同的测试，还有在这个不同的画质上面做一个平衡。
So I hope our tools and some of the methods we talked about can be useful in helping improve the quality of your products, and if you're working with cars, hopefully help save lives.
所以在我们刚刚介绍我们所提供的各种的软硬体的工具，还有这个应用上面，希望对你的产品和对你的研究都有所帮助，尤其是在汽车行业上面，并且能够因为这样而就是保护更多的生命，拯救更多的这个道路上的人。
All right, I have 5 minutes left. If anybody wants to ask any more questions.
我还有5分钟，有没有人还有其他的问题？
Otherwise, I hope it was a good use of your time, and thank you to Dunhua for arranging this, and thank you to Qing for translating.
如果没有的话，那就谢谢登华安排这一次的这个会议，也谢谢 Qing 来做这次的翻译。
So Jiang Bing Jun has asked if we're going to have a recording of the video. Yes, I will have a recording. And so if you drop me an email, henry@imatest.com, I can send you that recording afterwards.
郑明问说，是不是可以有这次今天早上会议的录影档？是你如果私信我，henry@imatest.com。现在Henry 有发布给大家，寄给我这个 email， 我可以把今天的录音档传给你。
Okay, well, I think that's the end of our event, and I appreciate. Oh, yep. Okay, that's the end. Thank you very much, and have a great day.
谢谢大家，祝福大家今天一天愉快，谢谢。
谢谢。
Thank you.